scale of 10?
I have one of them.
Alright, so today we're going to do some converting between degree form and radian form. And then we're going to be finding something called arc length. Now, degrees and radians are just ways to measure an angle. Like you guys have had degree forms for like ever, right? An angle and degree. Well, you can also measure an angle in something called the radian form, and it's used a lot in upper level math. It means like the same thing almost as a degree, it just looks different. It shows the same type of measure. So if you guys are going to find x to the nearest minute, does anybody remember how we have to handle that? Oh, good job. Yeah, second cosine. Make sure your calculator is in degree mode. Okay, so second cosine. Then we're going to put in 0.275. Yeah, 75. Right. Now this is going to give you guys your degrees, right? But how do you go to the nearest minute? What do you have to do? BMF. Nice. Second half. Super. Right, choice 4. Good.
And then is it greater or
yeah. So is this going to stay at 2 or go to 3? Stay at 2. Good. 74 degrees and 2 minutes. Nice. That's great. You guys remember this. So if this is like a 30 or more, we go up. All right. If not, stay 2. Sure. I believe. So 74 degrees and 2 minutes. Awesome. Okay. So the first thing, yeah.
So if it's like, if we're down to exactly 30, you go up or down?
You go up. Kind of like if it's a 5 or more, you go up. So 30 or more, we go up. Kind of same principle, I guess. Good question, Addie. All right. So the first thing we're going to do is something called converting degrees into radians. Now, radians usually has a pi in it. Like if anybody remembers your unit circle, you probably saw lots of things with pi's on it. All right. That's in radian form. So what we're going to do is convert from degrees to radians. Is we're going to multiply by pi over 180. Okay. So what it looks like is this. We're going to take our 135, we're going to multiply it by pi over 180. All right, it's just like a conversion, so you're always going to be multiplying by pi over 180. Right? I like to think that if I'm going into radian form, you always want a pi, so the pi would go on top, so pi over 180. So when you guys multiply your fractions, it's like saying top, bottom. So it's 135 pi over 180. But you guys would see this as an answer. They always want you to reduce this into simplest form. Right? Not the pi, just like the number. So what we're going to use is your calculator. It's probably the easiest and quickest way to do that. Right, so we're just going to type in 135 divided by 180, 3/4. Good job. Right, use your math fraction key. Oh, that was a good thing, Britt, that you did. Right, make sure you guys go into a fraction. You're not going to see this as a decimal ever. Like you won't see it 0.75 pi. It'll always be in a fraction. So we're going to use that 3/4. Okay. So your final answer will just look like this: 3 pi over 4, or 3/4 pi. Nope, pi just stays. So you're really just working with the numbers. Okay. So this is in radian form now. Right? So if you took 135 degrees and you wanted to know like what is that equal to in radians, well it equals 3/4 pi. Just a different way of expressing an angle measure. Let me do another one with you guys. Okay, so I have 100 degrees and I want to go into radians. Right? Since we want radians, we want a pi. So pi is going to go on top. So now when we do our multiplying, if it helps you to put this over 1, we can. So it's like 100 pi over 180, and then we want to reduce the 100 and the 180. Okay. All right, again, like we don't want to leave it like that, so go to your math key. Right, use your math fraction button. So 5 over 9, so it'd be like 5 pi over 9. 9, 5 pi over 9. How are we doing so far? Is everybody able to find the buttons, use your math fraction key? Why don't you guys try the next 3? See if you guys can get these. If anybody wants to just come up and write it, feel free. Always over 180. That conversion is never going to change.
Do you have an extra calculator?
Yeah, I was just going to grab one.
Thank you.
Anybody else need one?
Yeah.
Thank you. Oh wow, you're not old there. Oh, but you're small one, I'm sorry. Circles like this are bad. I know, nice. I told you guys, it's like a nice easy day. This is great. Thanks, Kayla. Beautiful conversion. This is not wrong if you guys wrote like 1 pi over 4 or 1 pi over 3. Not wrong, but you won't see the 1. Like if it's a multiple choice question, it'll just say like pi over 3. Yeah. Alright, good job. Okay. So now this is going the other direction. Alright, we just went from degrees into radians. This one's going from radians into degrees. So notice what happens with how you when you multiply by. It flips. Good job. Alright, so it flips. We're going to be using the reciprocal. There's 2p. Is that right? 2p? Yeah. 2p. Alright. Okay. So we're going to be multiplying this time by pi over 180. Oh yeah, 180 over 5, thank you, oh my god. Alright, so we're going to take our 2 pi over 3. Okay, so it's in radians, we want to go to degrees. A way I remember this one is that when you guys see degrees, do you ever see pi left in degrees? No, it goes away, right? So think about, if you wanted to go into degrees, where would the pi have to go away? The bottom, good. So that's kind of how I remember the 180 has to go on top here, the pi would have to be on the bottom. Because now, when you go to multiply these, what happens to the pi? They cancel very nicely. Good. So 2 times 180 is going to give us 360. Yep. Over 3 will give us 120 degrees. Right. Or another way people want to see this, 180 really equals pi. So another way people teach this is that they say, well, I can get rid of the pi and put 180 in its spot. So you're really doing the same thing. 2 times 180 over 3. If you guys can think about it that way too. I want you to know this because there's a special case where you have to know this to like handle it. So I'm going to show you guys with that every time just so it kind of helps you remember. Alright, so let's try the next one. Oh, here's a normal. Alright, so we're going to take this line, put the pi in the bottom. Alright, pi's are going to go away. We have 7 times 180. These numbers are huge. Then divided by 3, you get 420.
So that's your answer?
That's your answer, yep. They usually always have one of these conversions on every single equation. Okay. Why don't you guys try the next two so you can get these. Anybody wants to go up? Feel free.
Tell me to go up. I'll be the true man. No. Got it. You wouldn't see that, what I was just saying, sitting there. Don't need more. 5. 3. Okay.
Beautiful. Good try. Nice. How did you get here? All right, super. Thanks, Kayla. This looks pretty good, yeah? Okay, so take a look at the next one. The reason why I wanted you guys to do this, like 180 over pi, kind of like actually show it, is because of these special cases. I've been seeing more and more of this type of problem show up on the like recent exams rather than the easier conversion. But again, like you never know what the heck they're gonna do. So just take a second, read this one carefully. They went to the nearest tenth of a degree. The angle whose measure is 2.5 radians. Now this is a little bit weird because you have something that's in radians, but do you see a pi there? Yeah, there's no pi, it's missing the pi. So, alright, notice there's no pi in the radian measure. So when this happens, we still need to go from radians to degrees. So we're still going to be using the same conversion, right? So I have a radian, I want to go into degrees. So what do you guys have to multiply by?
180 over pi.
180 over pi, good. So same kind of conversion you guys did here. You were in radians, but you want to go to degrees. So we're still going to be multiplying by 180 over pi. Now the difference is here though, do you guys have pi's like to cancel? No. All right. So we don't have that pi to cancel anymore. So what we have to do is when you guys do your multiplying, okay, we're going to use the actual pi key in your calculator.
Is this supposed to be in a fraction?
Like, since you want it, you can leave it as a fraction if they said like it was an option for it, but they want you to go to the nearest 10th, so you actually do have to divide it. So what we're going to take is 2.5 times 180. Now we're going to have to divide by the actual pi key. Divided by the pi key is if you guys do second little caret, second caret gives you the pi. So you would get this long big answer. Okay, 143, and they want you nearest 10, so 0.2. 143, 0.2. Yeah, degrees. Thanks, Pam. Yeah, there's a degree. All right. This next one, and again, I kind of try to pull questions where, like, you guys get a pretty big variety of how they can be asked on your test. This is one I saw, like, one of the latest ones. Kind of incorporates two different techniques. So, wait a second. And they want us to the nearest minute, the angle whose measurement is 3.45 radians. Well, this is a little bit tricky because can you guys go right from radians to minutes? What do you have to find first? Degrees. Good job. You're so smart. Okay. Yes. Oh, wait, you guys. You're so good. All right. So we need degrees first. Okay. So your exact right page. You're going to do just what you did up here. Get it into degrees, and then we got to convert it into minutes. So we're going to take a 3.45 times 180 over pi. We don't have the pi's that cancel. We're going to use our pi key. 3.45 times 180. Right, now we're going to do 6.1 divided by pi. Alright, now this is it in degrees, right? Did you guys get this as degrees? Okay, so here's your degree form. Paige, what button do we need to go to minutes? Second, yeah, great job. We're going to look for choice 4, DMS, which changes it into degrees per minute per second. Okay, look at your minute, here it is. Okay, what's going to happen to it? Stay the same or go up? Okay, we got 13 seconds. Bam. Yep, so 197 degrees, 40 minutes. If this was like 32 seconds, then we would go up. If it was like, 40 seconds, then we would go up, because that's closer to 60, which is a minute. Remember, anything less than 30 stays the same. Yeah, kind of like 5, you go up.
You have to write the degrees
For this one, yes, you do, because it's like a specific type of measurement.
I have asked for many times.
Yeah, yeah. Yeah, you can't start at 40. Yeah. All right. Great. How are you guys doing so far? Not bad, easy? Okay. You're going to get one of those. You're going to get one of those on every single region, right? Some type of conversion. It's usually not more than one, but you got to know how to go degrees to radians, radians to degrees, or watch out for that special key, right, where you're using the pi key. Now, the reason why we use so much stuff in radian form is so you guys can actually solve problems, right? One problem that comes up is this problem of arc length. And what arc length is, it's a way to calculate the distance if you were going to like walk on a circle. Imagine if, I said earlier today, imagine if there was like an ant walking around the circle, and then they didn't like that. So I said, imagine if my pugs were walking on a circle, or you wanted to measure the distance that they walked. Okay, this is what the arc length shows. It actually shows you guys the distance on a curve like the arc of a circle. Okay. Now you're going to see these like special words when you're dealing with arc length. They're going to say something about like there's an arc length, a radius. Then I can call this a central angle. Okay, and the central angle is theta. And this is very, very important. Your angle that they give you has to be in radians. You want it to be in radian form. Because if it's not in radian form, what do you guys think you have to do? Degrees into radians, good for it. All right. So usually they're not too mean with these. Okay. One issue I see a lot though is when you guys are reading, be carefully pay attention to which one is the radius, which one's the radian. Because a lot of people just see RAD and they just kind of like don't read which one's which. So I see people mess that up a lot. Let's do. Okay. So first up is to draw a picture, right? If we need to, we just kind of substitute for some things in. So we have the length, find the length of a radius of a circle. So here's a little circle. I don't know what the radius is. We have a central angle. So some angle is 4.5, and it intercepts an arc of 9 meters. So the arc is this part. So this part's 9. Now I don't know what my little radius is. And again, if you guys don't need a picture, we need to draw. No, it's fine. All right. And if you guys are okay with just kind of figuring out what the central angle is, what the S is, and what the R is, and plugging it in, that's totally fine too. So which one of these do you guys think is the central angle? 4.5. Good. Great. And the arc. Which one's the arc? 9. Good. So S is the arc. And we don't know the radius. So you keep that X if you want to make it X, you keep it on, whatever you want. Okay. Unfortunately, this is a formula you do have to memorize, right? Theta equals S over R. Now, you can think about it this way. You're dealing with a circle, right, with this? Some kind of an arc. So you can use, like, the wheels on the bus song, because it's like a circle. Oh, good, Brett, you could join in. So you can think, like, theta equals S over R, S over R, S over R. Theta equals S over R to find the arc length. There you go. That's all I got for you. All right. So we could think like circles, theta equals S over R. I don't know. All right. So we plug this stuff in. So theta equals S over R. 4.5. We have 9 over R. If it helps you guys to put your whole numbers over 1, that's okay. So we're going to take our fractions, since we have 2 fractions with an equal sign, just cross multiply. So 4.5 times R. Good. And then 9 times 1 is just 9. We've got to get R alone by division. And so R equals 2. Very nice. Alright, that's it. Usually they're nice like this. Let's try this. So, just to make sure we all know what a pendulum is, someone used, it's like We heard lots of things. Yeah, it's like if you were gonna hypnotize somebody, like that kind of motion. Someone told me it was like the Miley Cyrus wrecking balls, like a pendulum. Yes, that is too. Like a grandfather clock. Okay. Basically a pendulum is something that kind of like swings back and forth. Okay, so all those things would be examples of pendulums. Okay. For some reason the Regents like the pendulum idea, but just to make sure you guys all know what that is. So here it's talking about a pendulum, right? It makes an angle of 3 radians. So what do you guys think the 3 radians represent?
The angle.
The angle. Good job. The central angle, because it's in radian form. It's nice. Okay. And the trip travels 18 feet. So imagine this is the tip. It travels 18 feet. What does this represent? Arc. Nice job. Good, Britt. Okay, so that's the meter 18. Now the length of the pendulum is this right here. You got maybe someone's thinking, well, how is that a radius? Well, if you imagine if you swung this pendulum all the way around. Oh my gosh, it's gonna freak out. There we go. Stop. All right, good, Katie. So you could kind of tell if you swung this all the way around, it would create a circle. Yeah, so this would be your radius. Okay, so we don't know what the radius is here. Why don't you guys try to set something up and see what you get. Do you guys get 6? Nice, good. Pretty easy so far. Kind of just like plugging stuff in. This is what I usually see on the test, right? More things that are like straightforward, not things that are super tricky. Over there. There we go. Okay, now if I do see things that are tricky, what they like are these questions. This is good. Take a second, right? I want you guys to think about this because I've seen these clock questions come on numerous times, and they're a little confusing. Once we talk about it, I think you guys will kind of see how you solve it, but I feel like this would be tough for you to go on to a Regents exam just to see. Yep, that's a good idea. I would draw a clock. Sounds like a good plan. Okay, we're talking about a clock, so let's get a picture. Oh, yeah. Alright, so I'm going to do a labeling of a clock. That's a little off. So that looks a little better. Right. Now, the period 4-5 class, they were all up in arms because my clock was not like super accurate. Now, when they give you guys these clock questions, if they have the hands of the clock are at 2:30, right? Don't think like so 100% like accurate. This is how they want you to like think of this. Where's the hour hand? At the 2. Okay, good. Okay, so there's your 2. Alright, where's the minute? 6. Okay, great. Okay. They were like arguing with me because they're like, well, it should be a little bit more past the 2. I'm like, the Regents doesn't want you to be that like, yeah, I guess it does kind of move, you know what I mean? But they're saying 2:30, they mean like the hour hand, minute hand. Alright, so don't like read too much into these. Okay, what they're asking guys for is to find the measure of the angle formed by the hands of the clock at 2:30. So we're looking for this part right in here. Okay, this is what we're looking for. Now, they want you guys to figure it out in degrees first and then change it into radians. So I want to let you guys kind of think about this. Talk with your neighbor. See if you can kind of think of some ways that we can figure out how many degrees are in between there. Okay, start from here. You don't know the radius. You'll go. This is just a conversion. Oh, you got to figure it. Nope. Nope. No formula for this one. Okay, you're getting closer, Angie.
I see where you got that down.
Sometimes you're really good at that. Yes, you do, Brittany. Brittany said you have to do something involving a circle. No, it's something with a circle. Not volume with a circle. My hand just closed. You have to do something with something, and you get to something. Yeah. Maddie, what do you think? All right, you're getting really close. Right, we have to do something with 360. Okay, here's your clue. If you guys need more like clues here, think about how many degrees are in a circle. 360, right? We all know that. There's 360 degrees if I went like in the entire circle. Okay? So what we need to figure out though is just the degrees between this part only.
Something with 270, right?
Think about the clock. There's something very special about the clock part. What do you think of this?
You want to start shouting out the answer?
Yeah, go ahead. I think she's got it. I see a calculator work going. Who said that? Yeah?
Between each number is 30.
Yes, good job.
You already had that. You guys are all jokes.
Okay, you guys are both great. Maddie, I like how you were very specific though. This is why the clock is handy. All right, we all know, I hope, with that 360 degrees, right? What did you divide this 360 by?
12.
12, because see how there's 12 little intervals in a clock? Right, so if we take 360 and we divide it by 12, we would get 30 degrees. What that means is that each of these little intervals is going to be 30 degrees. I know. Right, so together this is 120 degrees. Okay, you got that? Good, good. No, that would be like the answer to the first part A, 120 degrees.
Would that be that?
No, but this one's not even an arc length. We're going to get to an arc length one, but I wanted to give this to you guys in two separate things first, so I didn't make you go crazy. Alright, how would you guys get this into radians? What would we have to do? Good job. Pi over 180. Nice. So I'm going to take 120 times pi over 180. Right, make sure we reduce it. So should we 2 pi over 3? I like to think if you're going from degrees into radians, don't you usually see a pi in radian measure? So the pi would be on the top. Okay, let's think of this. I feel like we need something more. What about yeah, I kind of like look at the canceling part, or like where it should be left. What about we think about where the radian pi is rad? So you can think that's got to be on the top. I don't know. But that's the thing. If you guys can think of a good way to remember this conversion, let me know. Come up with something fun. All right, last one here. Now, this is where I see like something pretty difficult if you're dealing with an arc length kind of deal. All right. So if the minute hand of a clock measures 6 inches, how long is the arc traced by this hand from 1 to 130? All right. Well, we're gonna get our little clock going. Give yourself a nice little picture. It doesn't have to be perfect, just so you guys can kind of read it. Notice here, are you guys talking anything about the hour hand? No, they're just, I mean, we want to put an hour hand in, just going from like 1 o'clock to 1:30, but they're interested in the minute hand. So the minute hand is what we're imagining here. If you're at 1 o'clock, wouldn't the minute hand be like this in blue? Okay, so now if you're going to 1:30, it's going to have to go all the way down and around to end here. Does that make sense? A minute hand from 1/3? Okay, all right. Now, what we need to look at is to figure out, notice you see things in here that the minute hand measures 6 inches. We were talking about an arc, all right? They want to know how long is the arc here. So what kind of question do you guys think this is? What do you think? No DMS. Yes, good. Theta equals S over R. Good job. Okay. So theta equals theta, like TH. It looks like this. THETA. It's a Greek letter. It just represents like an angle measurement. We don't know. Oh yeah. Theta. Okay. So what do we know here? Do we know the radius? Do we know what this minute hand is going to be? Good, 6. We know that the R is 6. Okay. Now the central angle. Oh gosh. All right. So do we know this part here? No. I don't know if we know that. Can we figure it out? No. You can say yes. What do you think? 360 over what? Divided by 6, what do you say? Over 6, good. So what would that give you? Good job, 180. Very nice. Remember, same deal, there's 360 degrees here, right, in a circle. Right. Imagine the blue, how many sections was this? I got 60. Yeah. Oh, sorry. What am I doing now, maybe? Sorry, Sylvie. Kind of confusing me now. Jeez. So 360 over 6. What'd you guys get? 60. 60. Okay. Wait, am I missing something? Wait a second. No. Hang on. Wait. Okay. So, you know what? Let me go back. I'm messing this up. Sorry, guys. Alright, so we got 360, right? Okay. How can we tell each of these is worth? It's 30. Yeah. And 6. Yeah, you're right. Sorry, Stogie. I'm like messing up there. You're right. These are all 30 because we had to divide it by 12. Good. So when you add all these up, what do you guys get? 180. 180. All right, good. Thanks. Ding, ding. I know, she already had it. Okay. So can we have this go in degrees? No. Okay. What do you have to get it into? Radians. Okay. So you know when we're going into radians, we say pi on top over the 180. What's going to happen here? 180s are going to cancel. So we're left with just pi. Okay. All right. Do we know what the x is? No. No. Okay. So when you guys cross multiply that, 6 pi equals s. Good. Now you can also, it just depends how they leave it. If they say, you know, they don't say anything, this is fine. All right. What about if they said to the nearest like tenth? What would you guys have to do? Multiply it. Good. So you have to do like 6 times pi. Good. Yep. So you could also write it like that 18.8 if you wanted to get it in a decimal or something like that. So s equals 18.8. I don't like those. I know.